linear wave shaping. First, we go for what is wave shaping. Wave shaping. What is wave shaping means? It is defined as a process of generating new waveforms from older waveforms by using certain physical systems. What is wave shaping? It is the process of generating generating new waveforms from the older waveforms by employing certain physical system, by using some physical systems. It's called as wave shaping. So depend upon the physical system involved. So here, depend upon the physical system, involved, the methods of wave shaping may be classified into two. What are they means? One is linear wave shaping. Another is non-linear wave shaping. What is that I told? What is wave shaping? Hello? Amma vintunara?
Yes,
Are
sir.
you listening?
Yeah, sir.
What is wave shaping? It is
Yes,
a
sir.
process of generating the new waveforms from the older waveforms by using some physical systems. So depend upon the physical system, what you are going to involve, the methods of wave shaping are classified into linear wave shaping and non-linear wave shaping. In the syllabus also, you will be having a linear wave shaping. Under the linear wave shaping, you will be coming across the integrator and differentiator. Whereas in the non-linear wave shaping, we will be studying the clippers and clampers. So coming to this linear wave shaping, now we will discuss about the linear wave shaping. It involves the passage through linear systems. So it involves the pass of the, so here the passage of signal through linear systems. Again, it will be, for your understanding, I will tell you that is active and passive will be there in these linear systems, such as one is RC, or you can go for RL, or you can go for RLC circuits. And the operation involved are linear, such as what are the things are? One is integration. Next is differentiation. You will be having summation. You will be filtering, etc. So we will be concentrating on these two, integration and differentiation. Okay. When you ask for the definition of this one, linear wave shaping, so anywhere that is 2 marks, you can write this one. So you will write here the process whereby the form of a non-sinusoidal altered signal is altered by transmission through a linear network. A linear network is called linear wave shaping. So this is a definition related to this one. The process whereby the form of the non-sinusoidal signal is altered by transmission through a linear network is called linear wave shaping. When you talk about the non-linear wave shaping, so here we'll discuss here, that is a linear wave shaping, what I told. So the passage of the signal through linear systems, here we will be coming across RC, RL, RLC, that is RC and L components. The operation involved are linear, such as you will be going for the integration and differentiation. And when you go for the non-linear wave shaping, so here we will see here, that is a non-linear wave shaping. If you take up, it uses not only the linear passive elements such as what we have discussed, such as resistors, inductors, and capacitors, but also non-linear elements such as diodes. You can go for Zener diodes and transistors operating in non-linear region. The circuits used for non-linear wave shaping, one is clippers, another is clampers. Okay, so this is the general total introduction related to this wave shaping. What is the wave shaping, ma'am? What is wave shaping? Anyone? Just I told no. What is wave shaping?
A process on generating new waveforms.
New waveforms from the older ones by using
Certain
any physical systems. So based on the physical system involved and the method of wave shaping, we are going to classify this wave shaping into two types. One is linear wave shaping, another is non-linear wave shaping. So when you go for the linear wave shaping, the passage of signal through the linear system, such as the resistor, inductor, and capacitor, and operators involved in the linear form, such as we will be going for the integration and differentiation. When you go for the non-linear wave shaping, it not only uses the linear passive elements such as resistors, inductors, and capacitors, but it also uses the non-linear elements such as you will be using these diodes, Zener diodes, transistors, which operate in linear region. So the circuits which are going to have from this non-linear wave shaping are clippers and clampers. These two topics we will discuss in the after this particular topic. Understood? Up to this is okay. Now we go for the first one. We are going to have both the integrator and differentiator concept. Before going for that one, we will have to know what is the low pass circuit and high pass circuit. So we will first have the concerned concept related to this low pass circuit. low pass circuit. Low pass LPF. That is LPF. What do you know about this low pass circuit?
Which allows low signals.
Which allows
Low strength signals.
anyone? Ingarana Chapagalara, what is LPF?
It is also called integrator.
అది ఓకే అమ్మా. వాట్ ఈస్ లో పాస్ సర్క్యూట్? ఏం జరుగుతుంది ఇంట్లో?
Which allow low strength signals.
ఇంకొక వేరే వాళ్ళు లేరా చెప్పేదానికి? నువ్వు చెప్పింది ఓకే అమ్మా, కానీ సంథింగ్ దట్ ఈస్ మిస్సింగ్ ఇన్ దట్ వన్. బాయ్స్ వింటున్నారా లేదా మీరు అసలు ఫస్ట్?
Which allows low frequency.
Speak out. Okay. Boys కూడా ఎవరు చెప్పట్లేదు.
Sir, it is a filter that passes signal with a frequency lower than the cutoff frequency and attenuates signals with frequency higher than the cutoff frequency.
Okay. That is the definition. It allows low frequency signals and attenuates high frequency signals, and what concept blocks the high frequency signal. So in ideal concept, this is the ideal characteristics of this one. That is, this is said to be FC and this is said to be F, and this is said to be the, for example, this amplitude V you can consider. So this is the, from here to here, it is a pass band, you can say. This is the stop band. This is the stop band. So this is the cutoff frequency FC for the ideal concept. When you go for the actual characteristics of this one, this is the actual characteristics what we are drawing here. So this is F, and this is going to be the circuit. There is a characteristics. So we can say that this is you are going to take the 3 dB point. We will discuss now 3 dB. That is nothing but you can say V max by root 2, 1 by root 2 times. So when you project this one, you will be cutting at FC. So this is a cutoff frequency at 3 dB, at 3 dB point. So this is called as the pass band. It is allows the low frequency signals, but it is going to block the high frequency signals. This is stop band. This is stop band. Understood? This is stop band. When you go for the reverse of this one, high pass circuit, it's totally reverse. So the graph will be resembling like this. So you will be having this type of graph here. So this thing we'll discuss in the next topic. Understood? Emma? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Okay, Emma. LPF, this low pass filter, again, for your understanding, I'm telling. So it is active LPF is there. LPF, active LPF, low pass filter. And this is a passive low pass filter. So in this one, you will be using the op-amp. So these operational amplifiers, you will be studying in the higher classes, operational amplifier, and you will be using the transistors also, transistors in this one. Whereas in this one, you will be using R, C, and L. So we are going to have this topic in this particular concept. When you talk about the advantages, that is the advantages of the active LPF, active LPF. So it provide, so here it provide gain to the input signal, when you talk about the active LPF. That is similarly when you go for the passive LPF, so here the output will be less than the input. So these things for your only understanding purpose are not necessary for you when you're writing the concerned question which arises in the examination. Now we go for the explanation of this one. Only the related to the low pass circuit I'm telling. Where is the integrator will study after this topic. So you can see the circuit of this one. This is the circuit. So this is R and this is C, and you are having this to be V0 and this is set to be Vin. So this is plus and this is minus and this is plus and this is minus. What are the components you're using here? So you are using one resistor and one capacitor. Okay. So here, when you see here in this one, the points to be discussed. One thing is XC. If you see here, SC is nothing but the. So here this R is related to the resistance and C is related to the reactance XC. XC is nothing but 1 by omega C here. See, as frequency, that is, if you are again you can expand this one, there is nothing but 1 by 2 pi FC. So as F, that is frequency, F decreases, if this decreases this value, it is going to decrease. What is the XC value? What will be the XC value?
Increase.
It increases. So if this is going to be increased, so obviously the V0 is also going to be increased. So that means you can say that if F is set to be 0, less than, I'm saying F is set to be 0, 1 by 0, what is the XC value here?
Infinity.
Infinity. Infinity means infinite. Okay. X is said to be infinite. So when X is said to be infinite value, well, the V0 is nothing but V input. So whatever be the output that is there here, so is nothing but V input. When the condition is, that is F is equal to 0.
Zero.
F is equal to 0. Understood? Similarly,
Yes, sir.
when we go for the frequency is set to be increased, then XC, what is the condition of XC? It is going to reduce. It is going to reduce. Similarly, the V0 is going to be reduced. So we can say that F is equal to infinite. That is 1 by infinity. What is the value of XC?
Zero.
X is 0. So if X is set to be 0, then V0 is set to be 0. V0 is set to be 0. These conditions you have to see for the LPF and as well as the HPF. HPF somewhat it going to differ in this one. Up to this is okay?
Yes, sir.
Okay, these conditions you have to remember. So here next is, we are going to calculate the, if you want to calculate the V0 value, V0 is nothing but you can write it as XC by XC plus R into VM. This is okay related to this circuit. So this is nothing but XC by XC plus R into VM. So in this becomes mod XC by, so mod XC plus R into Vn. Now I'm taking the term of this one, that is R square plus XC square, R square per XC square. So here at cutoff frequency, so at cutoff frequency, the output will be 1 by root 2 of Vn, 1 by root 2 of Vn, and the attenuation, or you can say gain will be 1 by root 2. So if you say take the value of this one, if you take the value of this one, that is said to be 1 by root 2, is nothing but, I can write this things XC in the form of 1 by omega C. So I can write this to be 1 by omega C. This I can write it as 1 by, that is R square plus 1 by omega C whole square. Ila raskochu kadamma? Ila raskocha? Hello? Say yes or
Yes,
no?
sir.
Okay.
Yes, sir.
Now I'm squaring. Oh ma, okay ma. Squaring on both sides.
Yes, sir.
Squaring on both sides. I'm squaring on both sides. Then what is the relation here? This becomes 1 by 2 this becomes 1 by omega c whole square by, so root I'm going to eliminate that one, that goes off, that becomes 1 by omega c whole square. So you take the common term in the denominator. So what it becomes, so this I can write it as, so this becomes 1 by omega c whole square by, so this I can write as r square omega square c square plus 1 by omega c whole square. So this thing and these things I can cancel now. I can cancel now. So now I can write it as 1 by 2 is nothing but 1 by r square omega square c square plus 1. So now I'm reshuffle the terms, that is 1 plus r square omega square c square is equal to 2. So r square omega square c square is equal to 1. So this becomes, you want to have r square is equal to 1 by omega square c square. This you can write it as r is equal to 1 by omega c, or you can say omega is equal to 1 by rc. So you got a relation here.
Sir, squaring on both sides అంటే
Emma?
1 by 4 అవుతుంది సార్. స్క్వేరింగ్ ఆన్ బోత్ సైడ్స్ అన్నారు కదా సార్
ఎక్కడమ్మా?
పైన సార్
1 by 2,
1 by
1 by root 2 కదమ్మా,
1
root 2
by
కదమ్మా,
root.
ఇది 1 by root 2 times 3dB కదమ్మా.
ఓకే సార్,
ఓకే,
ఓకే సార్.
1 by root 2, ఇది root 2 బాబు, ఇది root 2, ఇది కొద్దిగా అండర్స్టాండ్ చేసుకుంది, స్లిప్ అవుతుంటుంది, స్లిప్ పెన్. 1 by root 2, దాన్ని స్క్వేర్ చేస్తే ఏమవుతుంది, 1 by 2 అవుతుంది. ఓకేనా? ఎనీ డౌట్? హలో,
No, sir.
ఏమన్నా మాట్లాడండి. ఎస్ సార్, నో?
No, sir.
No, sir.
నో
No,
సార్
sir.
అంటే అది అర్థం కాలేదనా, అర్థమైందనా?
No doubt, sir.
నో డౌట్ అన్నా?
అర్థమైంది
ఓకే,
సార్.
నో సార్ అంటే నాకు మళ్ళీ ambiguity-లో ఉంటుంది, అవునా కాదా అని. ఓకే, సో హియర్ omega is nothing but you can substitute 2 pi f. Here we are going to take the 2 pi fc. So this relation you can write it as fc is equal to 1 by 2 pi rc. ఇది రాసుకోవచ్చు కదా, దీన్ని, ఈ టర్మ్ ని ఇలా రాసుకోవచ్చు. ఓకే, here if you see the respective waveforms, suppose this one, this is the thing, this is a v in. So the concerned waveform, generally we'll think of this is the waveform what you are going to give. So the output, that is v naught, v out, is going to have like this. We will be having this type of waveform. Okay, and when you are going to have the phase angle, if you increase the input frequency, that is, if we are going to increase the input frequency, not only the output of the signal will reduce, but also the phase gets changed. So when you are going to increase the, if you are going to increase the input frequency, the output signal not only is going to be reduced, but also the phase of the signal is going to be changed. So if you see the concerned, this output waveform, the phase shift will be there. This is the phase shift. It will be starting somewhere here, and this is the waveform what you are going to have. Understood? So in this one, now we are going to take the phase angle of this one. Phase is calculated as minus tan inverse of omega cr is the relation in this one. So we are going to take the conditions here. So the cursor ekkodo kanapadatla. Okay, so if omega is set to be 0, then phase angle you can calculate it as minus tan inverse of, so this becomes 0. So tan inverse of 0, what is the angle?
0
degrees. So similarly, case 1, this is the case 1, And similarly, when you go for the case 2, so in this case 2, if you are going to have the value, that is if omega is said to be omega c. So if then the value becomes minus tan inverse of, so this becomes omega is equal to omega c, this becomes 1, tan inverse of 1. So when tan inverse of 1, what is the value? This
45.
is 45 degrees, minus 45 degrees. Now when you go for the case 3, if omega is set to infinity, so phase angle is minus tan inverse of infinity. So what is the value? Tan inverse of
90 degrees.
minus 90 degrees. So you can see the shift in the particular phase depend upon the concerned omega value. So when you draw the note cheskunnara, I'm moving the slide ma, meer note cheskuntunnara leda?
Yes, sir. Yes, sir.
Yes, sir.
ఎక్కడ ఉంటే హోల్డ్ చేయమంటే హోల్డ్ చేస్తాం. Okay. Now we can draw the concerned phase angle. So this is what the phase for frequency. So this is the characteristics what you're going to do. 0 degrees, and you say that this is to be minus 40 lakhs the input by 45 degrees by 45 degrees. And at cutoff frequency, you can say at cutoff frequency, that is at cutoff frequency, R is equal to Xc. R is equal to Xc. That is the condition. So we can have the phase angle is 45 degrees. The phase angle is 45 degrees, and the output power is half of the input power. So when the concerned phase angle is said to be 45 degrees and the output power is said to be half of the input power, the output power is 0.707. So what is this 0.707? That is 1 by root 2. Already we have specified. That is 1 by root 2. That is 0.70 times the maximum value of voltage. That is Vmax. So this becomes, you can see how you're going to get this value. So already I have specified that is F is equal to 1 by 2 pi RC. So this becomes R is nothing but 1 by 2 pi FC. This is nothing but, what is this? 1 by 2 pi FC. This becomes XC. So R is nothing but XC. Okay. So the frequency at which the capacitive reactance is equal to the resistance of the circuit is called the cutoff frequency. So the condition, what is the cutoff frequency means the frequency at which the capacitive reactance Xc is equal to the resistance of the circuit is called the cutoff frequency. Or you can also define as the other point, the frequency at which the gain is 1 by root 2 times of the maximum of value is called as the cutoff frequency. Anything you can write it here. I will note down here. So the frequency at which the gain that is nothing but A is 1 by root 2 of the root 2, that is of its maximum value. Of its maximum value is called the cutoff frequency. What is cutoff frequency means, then you have to define this one. Understood?
Yes, sir.
So we'll see one example related to this one. So I will show an example here. So you can see an example. So I'm taking one circuit here, same circuit. Example. This one. We are giving the input and you are taking the respective output here V naught. This is said to be 1 kilo ohm and this is said to be 0.1 microfarads and this is 10 volts and 2 kilohertz. So this is the thing what has been given. We know the cutoff frequency. We know the cutoff frequency. Cutoff frequency. How to calculate? FC is equal to
R.
FC is equal to
1 by 2 pi
2 pi
FC.
RC.
2 pi RC. ఇది చెప్పాలి. Okay. FC is equal to 1 by 2 pi RC. So this becomes 1 by, you can calculate this one, 2 pi into what is the 10 R value? ఎంత ఉంది అక్కడ?
1 kilo ohms, sir.
1 kilo ohm
10 cube.
into 0.1 microfarad. So calculate and tell the value. What is FC value? చెప్పండి. బాయ్స్ మీరు కూడా చేయండి రమ్మా. Give the value FC. Hello.
159.15 farad. Frequency Hz.
కిలోలో మార్చుమా.
0.159. 0.15.
1.59 కిలోహెర్ట్జ్ వస్తాయి చూడమ్మా.
1.592, sir.
సర్లే 2 వదిలేలే. 1.59 వచ్చిందా? హైయర్ వాల్యూ.
Yes, sir.
ఇది వచ్చిందా అందరికి? బాయ్స్ వచ్చిందమ్మా?
Yes, sir.
Yes, sir.
Okay. Now we calculate that is FC cutoff frequency. Now V out at what is the value that has been given? Input enta 2 kilohertz. 2 kilohertz input. అదే కదా మనం తీసుకున్నాం ఇక్కడ. V out ఎంత ఇచ్చినాడు అక్కడ? 2 kilohertz ఇచ్చాడు. So V out can be calculated as per the formula what we have done, Xc by R square plus Xc square into Vn. Okay. Value of Xc at 2 kilohertz frequency. If we calculate first, so Xc is nothing but 1 by 2 pi Fc. 1 by 2 into pi into F value ఎంత చేస్తున్నాం ఇప్పుడు 2 kilohertz 2 into 10 to the power of 3 into what is the C value 0.1 into 10 to the power of minus 6. You calculate what is the Xc value. You త్వరగా చేస్తాను త్వరగా చెప్తాను. హలో
1.59.
అన్ని తప్పు చెప్తున్నాను ఈరోజు. 1 by 2 pi into 2 into 10 to the power of 3 into 0.1 into 10 to the power minus 6. 796. పాయింట్లు వదిలే. ఏమన్నా లావణ్య నాన్న కదా చెప్తున్నావు నువ్వు?
Yes, sir. 4
తప్పు
బదులు 2
చెప్తున్నావు.
పెట్టుకున్నారు, sir. 4
అలా
బదులు
చెప్తే ఎట్లా? రేపు ఎగ్జామ్ అట్లా చెప్తావు నువ్వు. సో నెక్స్ట్ వి అవుట్. సో వి క్యాలిక్యులేట్ ఎక్సీ వాల్యూ మనకు వచ్చింది కదా, ఎక్సీ బై రూట్ ఆఫ్ ఆర్ స్క్వేర్ ప్లస్ ఎక్సీ స్క్వేర్. సో దిస్ బికమ్ ఇంటూ విఎన్. విఎన్ ఉంది. సో దిస్ బికమ్ 796. విఎన్ ఎంతమ్మా? సర్క్యూట్ లో విఎన్ ఎంత ఇచ్చాను?
10 volts.
10 ఇచ్చాను. 10 by square root of this is r 1000 square plus 796 square. So you calculate and tell కరెక్ట్ గా చెప్పండి.
Six point two two, sir.
ఓకే 6 పాయింట్ ఏంటవి?
Volts.
6.22 volts. So V out is nothing but 6.22 volts. ఎంత ఇన్పుట్ కు V ఎంత ఇచ్చాం మనము? 10 volts ఇచ్చాం. 2 కిలోహెర్ట్జ్ ఫ్రీక్వెన్సీతో ఆపరేట్ చేస్తే అవుట్పుట్ ఎంత వస్తుంది? 6.22 volts డ్రాప్ అయింది. మరి 6.22 volts you are going to have. Okay, at 2 kilohertz the output V naught is 6.22 volts. So if you see the concerned characteristics, if you draw, so this is the characteristics what I'm going to draw here. So this you can see here. So first one is the cutoff frequency. Somebody draw this. So this is the characteristics. So you can take this is to be the FC. So you can say that calculated value. What is the value for this one? 1.59 kilohertz. Now this is the value what you got. This is for this. Suppose this is concerned to 2 kilohertz. 2 kilohertz ekkada cut avutumma? This is 6.22 volts. So this is the respective value. You can share the change of this one. Suppose if you want to the 2 kilohertz signal is attenuated as much as possible, then we have to go for higher order filters. If you are going to take up the higher order filters, this is the thing what we can have. The general characteristics. So this is, you can say, this is the first order one. If you take the 3 dB value, that is 1 by root 2. So it is going to cut off at say FC, and this is the first order, and the stop band that is going to be that is dropped by 20 dB by decade. This is going to drop by 20 dB. So suppose if you are going to have the higher orders, so this is going to have more sharp of this one. So this you can say this is the second order. This is second order. The second order is dropped by minus 40 dB by decade. Likewise, if you want to have the nth order, this acts as, that is minus, you can write it as nth order one, that is 2 to the power of, that is 2 to the power of n into minus 20 dB. How many stages? Based on the stages, you can write up this particular thing, second, ninth order. Now if you write the first order one, the respective output. So I'm writing this first order. First order. So V out is expressed as 1 by root 2 V in. When you go for the second order one, the second order, it is expressed as V out is equal to 1 by root 2 of V in. Similarly, if you go for the nth order, so V out is expressed as 1 by root 2 of n V in. So these higher orders can be higher order terms can be obtained by cascading. Cascading means connecting one stage to the other stage. Now you have seen this first stage. This is R1 and this is C1. Now the second stage is this is R2, followed with the other stage that is C2, and so on. You can have the respective stages. So this cascading of the RC stages are done based on the condition that the second stage should not load the should not get loaded with the first order. What you are going to have, this on the first stage should not get loaded with the second stage. This is the second stage. It should not be loaded. To avoid the loading, the condition is R2 should be greater than, that is equal to 10 to the power 10 R1. R2 should be, the condition is R2 should be equal to 10 R1. This is one of the conditions. So this is the general things what I have discussed related to this low pass filter. To this, any doubt? Amma? Hello?
No, sir. Sir, cascade.
Now we go for the cascading. These things we'll study in the higher classes also. దీన్ని క్యాస్కేడ్ అంటారమ్మా. ఇక్కడ నేను మీకు స్టేజ్ రాసానా, ఒక స్టేజ్ ఇంకో స్టేజ్ కనెక్ట్ చేస్తున్నాం కదా, ఇది ఒక స్టేజ్, దీన్ని ఇంకో స్టేజ్ తో కనెక్ట్ చేస్తున్నాం, దీన్ని క్యాస్కేడ్ అంటారు. అంటే కనెక్టింగ్ వన్ స్టేజ్ విత్ అదర్ స్టేజ్. ఇవి మనం నెక్స్ట్ ఆర్సీ కపుల్డ్ యాంప్లిఫైర్స్ లో మల్టీ స్టేజ్ యాంప్లిఫైర్స్ చదువుతాం. ఇప్పుడు ఓన్లీ జస్ట్ ఏంటంటే మీకు అండర్స్టాండింగ్ కోసం. సో హయ్యర్ ఆర్డర్ టర్మ్స్ ఎలా వస్తాయి సార్ అని అడిగినప్పుడు హయ్యర్ ఆర్డర్ టర్మ్స్ ఎలా అవుతుందంటే ఇది ఫస్ట్ ఆర్డర్ టర్మ్, ఇది ఫస్ట్ ఆర్డర్. దీన్ని మళ్ళీ సెకండ్ ఆర్డర్ కనెక్ట్ చేయాలంటే ఇంకో ఆర్సీ కనెక్ట్ చేస్తాం, థర్డ్ ఆర్డర్ అంటే ఇంకో ఆర్సీ కనెక్ట్ చేస్తాం. ఈ కనెక్టివిటీని ఒకదాని నుంచి ఒకదాని కనెక్ట్ చేసాన్ని క్యాస్కేడింగ్ అంటాం. కానీ కండిషన్ ఏంటంటే ఈ ఫస్ట్ క్యాస్కేడ్ స్టేజ్ సెకండ్ స్టేజ్ తో లోడ్ కాకూడదు. లోడ్ అయినప్పుడు అంతా డ్రాప్ అవుతుంది. ఇప్పుడు దాని కండిషన్ ఏంటంటే దిస్ ఇస్ ద కండిషన్ టు మేక్ ఇట్ బ్యాలెన్స్, దట్ ఈస్ R2 should be 10 R1. So many things to be discussed. This is not necessary for you. Only for your understanding, I have given all the explanation related to the low pass filter. Understood? The same thing I will tell for the high pass filter also. Then we go for the differentiator in that particular concept. Can arthamaina meeku? Hello.
Yes, sir.
Boys, meeku arthamaindra babu meeku? Hello. ఎవరే మాట్లాడట్లేదు. Shall I continue?
Yes, sir.
Second period కూడా ఉంది కదా boys. Nobody is there. No boys there in the class.
Yes, sir.
అర్థమైందా లేదా మీకు ఇంతవరకు చెప్పింది?
ఎస్ సార్.
ఎస్ సార్ అంటున్నారు, వెళ్ళిపోతున్నారు.
అర్థమైంది సార్.
అర్థమైందా లేదా? ఓకే 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 అమ్మా, ఓకే. మీరు చెప్తే నేను కూడా సాటిస్ఫై అవుతా కదా, మీరు అర్థమైందా లేదా నాకు తెలియాలి కదా. ఓకే, నెక్స్ట్ వి గో ఫర్ ద low pass RC circuit as an integrator. Is it visible amma?
No, sir.
No, sir.
No, sir.
Okay, ఒక్క నిమిషం స్క్రీన్ షేర్ చేస్తాను. ఇప్పుడమ్మా
Yes, sir.
Yes, sir.
ఇది మీకు మెయిన్ ఎగ్జామ్స్ కు యూజ్ అవుతుంది మా. దిస్ ఈస్ ఆస్క్డ్ ఇన్ ద ఎగ్జామినేషన్, లో పాస్ ఆర్సీ సర్క్యూట్. Low pass RC circuit as integrator. This you make it clear. Okay. Now we are again taking the same circuit. This is the circuit. This is a C and this is R, and this is nothing but V naught of T, and this is VI of T. And the current that is flowing is I of T. So voltage across this one is said to be VR, and across this one to be VC. Note cheskondi. So according to KVL, Kirchhoff voltage law, at any instant of time, now V of t can be noted as this V of t. V of t is nothing but VR plus VC. This is okay? VR plus VC. ఒక నిమిషం పేజెస్ అనేది సెట్ చేసుకొని చెప్తాను. Okay, up to this is okay. Hello.
Yes, sir.
Only thing is V of VI, that is input, is nothing but VR plus VC. Here, time constant, that is said to be tau of the circuit. Time constant is said to be tau of the circuit is RC in seconds. RC in seconds. So this RC value, time constant. So we will be comparing with the input signal, that is input time period. So here the conditions what you have to take up is, the first condition is, if the time constant is very large, then the capacitor, what it will do? The capacitor charges very slowly. That means most of the input voltage will appear, where it appear? Across the resistor, and there will be negligible voltage across the capacitor. So what is the condition here? The time constant is very large. So here the time constant is very large. The capacitor charges very slowly. So this value is said to be RC. మనం ఎప్పుడైతే కన్స్ట్రక్ట్ చేస్తున్నామో, the time constant of the circuit is said to be RC in seconds. If the time constant said to be very large, the capacitor charges very slowly. That means the most of the input voltage will going to be appear at the resistor, and there will be negligible voltage of the capacitor. So you can have the understanding here. So this is the circuit. If I say this is R and this is said to be C, here the input is said to be 5 volts, and this is going to be a negligible voltage, that is going to charge. It takes much time, that is take 0.001. Then what is the R value? It becomes 4.99 volts. Onagada.
Yes,
So
sir.
this much of voltage is there. Then what is the remaining voltage? It is across the resistor R. So we can also say that this VR is approximately Vin. Tapachama is said to be, VR is said to be approximately Vin. So we can write it here. VR is approximately Vi of t. So this is the condition when it is going to take up large time to charge. It is going to be charged slowly. So most of the voltage is going to appear across the resistor and negligible voltage across the capacitor. Now the second condition The current in the loop, the current in the loop is mainly decided by voltage across capacitor, across resistor. Because most of the voltage is across the resistor, we are going to have the current in the loop is mainly decided by the voltage across the resistor. Their I of t. What is I of t now? As per the circuit,
VR.
మీరు వింటున్నారా లేదా? VR by I is nothing but V by R. That is VR by R. This is nothing but V of t by R. Okay. ఎక్కడ చూస్తున్నాం మనము కరెంట్ across the resistor, that is VR by R. That is VR is nothing but approximately said to be VI of t. This becomes VI of t by R. Now the third point, the voltage across capacitor. What voltage? Output voltage. Voltage across capacitor. That is nothing but output voltage. That is V naught of t. What is this V naught of t? Is written as circuit lo chudandi. This is, come back and see the concerned circuit. This is the voltage across the capacitor. This becomes 1, that is 1 by C integral of I of t dt. You can write this voltage across this capacitor is 1 by C integral of I of t dt. So what is this I of t? You put the value here, I of t from the above equation. This is Vi of t by R into dt. Okay. Now you can write this value by as 1 by RC. You just take out the R outside. This becomes integral of Vi of t dt. What is this one? V naught of t. How is it? This expression? You can say that this V naught of t is proportional to
Integral of
the integration of input of Vi of, that is input. Intena? Where RC is said to be constant. Is said to be constant. So you can say that the output voltage is proportional to integration of input voltage. When, what is the condition? When time constant of the circuit, our time constant circuit is
Constant.
when the time constant of the circuit is very large. Very large. This is the condition. So the RC low pass circuit works as integrator. So if the question is there, how the RC low pass circuit works as an integrator, then you have to explain this particular thing. You have to draw the circuit diagram. You have to take respective conditions, case 1, case 2, and case 3, and you have to specify the things. That is V naught of t is nothing but 1 by RC integral of Va of t dt. Understood? Any doubt? Hello?
No, sir.
Okay. Some other points related to this one is the output waveform of the integrating circuit depends upon the time constant of the circuit and shape of the input wave. So you can have the respective points here. So the output waveform from common which circuit? Integrating circuit depends upon the time constant of the circuit. అదే కదా మనం చేసాం ఇప్పుడు. And shape of the input wave. దేని మీద డిపెండ్ అవుతుందా అవుట్పుట్ వేవ్ ఫామ్ ఆఫ్ ది ఇంటిగ్రేటింగ్ సర్క్యూట్? ఒకటి డిపెండ్స్ అపాన్ ది టైమ్ కాన్స్టెంట్ ఆఫ్ ది సర్క్యూట్ RC and also the shape of the input wave, whatever the shape you are going to give. Okay, first one, when the input wave is square wave, output will be a triangular wave. ఇది మీకు ల్యాబ్ లో కూడా ఉందమ్మా, ఇచ్చాను కదా మీకు. RC, దట్ ఈస్ ఇంటిగ్రేటర్ అండ్ డిఫరెన్షియేటర్ ఉంది కదా, చూసారా మాన్యువల్.